The Vulkan API. So let's see the brief summary of the Vulkan API. Okay, Vulkan is a very low-level cross-platform and graphics and computing API. Well, it is low-level. What does it mean? Vulkan is very verbose. Unlike OpenGL, it handles almost every individual GPU process manually. Well, since Vulkan is verbose, unlike OpenGL, it will have to handle every GPU process manually. GPU provides a lot of features like swap chain and other like frame buffers and a lot more stuff that we will discuss onward in the course. But we will have to handle each one of those processes and features by ourselves using programming, right? So what actually the verbose means? Well, we will see that onwards. And what is OpenGL? Well, that one as well. We will see that onwards. So it says it's cross-platform. What the cross-platform means? Well, unlike the Direct 3D, which is a graphics API specifically for the Windows operating system, um, Vulkan is cross-platform. It can run on any platform like macOS or iOS or Linux or Windows or whatnot, everything, right? But on um, on macOS, it requires some additional work to operate, and I will just show you where you can check it out, like what additional work should we do to work with macOS. If you have macOS, then I'll teach you what you'll have to do and to set it up on your system. So, okay, we've discussed the graphics. What is graphics basically? So, graphics basically used for processing graphics data on the GPU. Okay, we draw stuff on the screen, right? Like triangles or squares or a lot more stuff. We draw things on our screen. We draw graphics on the screen, right? So GPU basically handles this kind of graphical data, like for example, the position of the vertices and processing those vertex points and stuff like that. These all are controlled by the GPU. And the point, the vertex positions and colors and stuff like that, this whole stuff is known as the graphics data or graphical data. And this whole stuff is collectively called as graphics. Well, but then what is computing? Since it is a computing API as well, so computing can be used for generic parallel programming tasks, much like OpenCL. If you are familiar with OpenCL, then you'll have idea about what is computing stuff and like that. Okay, so what is parallel programming tasks? Like it can include like um, multitasking and stuff like that. So this is what we call as computing. And for those people who are on macOS and iOS, I will just recommend them to go to this provided link, that is https://moltenGL.com/moltenvk/. They'll provide you the documentation, like what you'll have to do to set up Vulkan API on your macOS or iOS and stuff like that. Okay, so now let's come to the history of the Vulkan API. Okay, so first let's see what is OpenGL. Well, OpenGL is actually the predecessor of the Vulkan API. Like you can say a father of Vulkan API, right? So OpenGL is basically a high-level API. Like it works the same like Vulkan API, but it doesn't provide much features. It is like not much like low level. It is very high level. It doesn't provide us more features. It doesn't let us control much more stuff, right? As like Vulkan does. So OpenGL is basically a cross-platform graphics API, exactly like Vulkan API, as Vulkan API is also a cross-platform API, and it is a cross-platform alternative to the Direct 3D. Yeah. So directory is like we discussed that it is a platform specific API for Windows graphics API, and the OpenGL is cross-platform like Vulkan API. And before Vulkan was announced, OpenGL SQL was expected. They expected OpenGL SQL before the Vulkan API, and well, Vulkan was introduced, and OpenGL SQL was just cancelled, right? And it was often referred to as this Vulkan is often referred to as GL Next. And in 2015, announced as Vulkan API was announced as the successor of OpenGL, and yeah, that's what we already discussed. So Vulkan API is said to be much more lower level than OpenGL and Directory 12. Yeah, that's true. Like OpenGL is high level, Directory is high level. You don't need to write a lot of code and handle a lot of GPU features to work with it. But Vulkan requires you to do that. So, but OpenGL Directory, they just don't need you to do that. Well, Vulkan is supported by a group called Leonard G, and Vulkan 1.1 was released in 2018. Before that, Vulkan 1.0 was being used. Okay, Vulkan is very verbose. What it means? Well, it means there will be a lot of code. Well, GPUs are complicated, and Vulkan lets us handle all of those complications by ourselves. But, well, if GPUs are complicated and Vulkan let us handle all of that complications, but why do we need to handle so much complications? GPUs are complicated, but why do we need to handle that by ourselves? Well, that is because the more control you have, the more optimized your programs will be. Like what? Just don't understand, right? Yeah, let me explain. For example, I want to create an open world game. Like, you might have played GTA 5 or any of the GTA games, which are open world games, right? So you'll have to optimize your program for the open world games then. Or if you want to make a closed world game, for example, you might have played Hitman or any other one like I don't know. So in that case, you will have to optimize your program to that specific scenario. Like for example, if I want to make open world game, in that case, I will have to render the sky stuff and the land stuff and a lot of more stuff like trees and stuff like that. There are a lot of complications, right? But for closed world games in which you just have to interpret the buildings and stuff like that, then you just don't need to render the sky and land and the grass and trees, stuff like that, right? So you'll have to optimize your program according to your needs. For example, you just don't need some specific feature in a game. So why using that feature then for a game that doesn't need that feature? Well, it reduced the program optimization. So to keep our program optimized, we have to take out the stuff that are not required. And this is what we need. And Vulkan allows that to do that things. Like if we have more control, then we can control that application in all aspects. Okay, the code is not complex. Yeah, that's true. We we will have to write a lot of code, but the code is not complex. Basically, they are just filling the blanks, creating objects, instantiating the structures, and filling in the stuff, and that's it. That's all just we need to do. And this is there are no complicated things, right? Things are simple, but very detailed, and we just need to write a lot of code, like thousands of lines of code. And a deep understanding of memory management is required. Yeah, that's so true. You need to be familiar with dynamic memory allocations and arrays and data structures and stuff like that, how to handle them, and a lot of stuff like that, like typecasting, reinterpret cast, or stuff like that. So, like pointers and stuff like that, you'll have to be familiar with those kind of stuff. And I assume you have good understanding of C++ programming language. Yeah, Since this course is based on C++ programming, so you will have to be familiar with the C++ programming